Thermodynamics is so sad. E-I-E-I-O. Hello, ladies and gentlemen. Today we're going to learn about the laws of thermodynamics, or the nihilism in physics. The three laws, why they are important. Energy and thermodynamics describes to us why there is a requirement for heat and for work. The first law, aka you cannot win. Matter cannot be created nor destroyed. The amount of work something can do is determined by the amount of energy that is provided. The amount of things that we have in this world is finite and it is limited. The amount of energy we have in this world is finite and is limited. When we talk about matter and energy within a system, we often take a look at it as if nothing will enter the system or leave the system. And the equation that we have in order to describe this is delta U is equal to Q plus W, where U is the internal energy, Q is the energy transferred to a system by heating or adding energy, and W is the work done on a system. Remember, if you do work on a system, you are increasing the energy of that system. So here we have an example of the first law of thermodynamics. We have a piece of newspaper, and the newspaper is made up of all types of molecules and chemical bonds. So those chemical bonds all have some form of energy. So if you release the chemical bonds and you release the energy, you're releasing heat, or the energy that is stored within those bonds. Now, eventually, the newspaper will stop burning, and that's because you used up all of the energy that was available within the newspaper. First law problems. Some energy always escapes. This leads us to not having 100% efficient systems, which basically means that no machine will ever be 100% efficient. Now, this is something that plagues engineers and scientists for the longest time. They tried to make a machine that would run perfectly all the time. It won't ever break down. You won't ever need to repair it. And you only need to get it started once and it will run forever. And this is what we call a perpetual motion machine. And nothing in this world ever comes close to that. For example, us as humans only obtain about 10% of the energy that we obtain from our food. So about 90% of that energy is lost. It's useless. It's made into different forms of energy and it's released as heat. The car engines that we use is a great example of how the car engine just is horrendous as a machine. And we know this because if you turn on your car for maybe about a minute or two, the engine gets super hot. All of that heat that radiates from the engine is wasted energy. It's just energy that is escaping into the environment. So why it's sad? Well, if you think about it, no matter what you do, nothing you ever create will ever be new. Nothing will ever be new. Everything comes from something before it. Everything is old. Everything is rehashed. Everything's a repeat. Everything's a rerun. And saddest of all, nothing will ever be perfect. All right, the second law, you can't break even. Energy can't go from a cold source to a hot source. So remember, a cold source is an environment or a system where there is not a lot of energy. There is not a lot of kinetic energy. So we can't go from something that isn't there to something that is there. Okay, which means that disorder always increases in the universe. And this disorder is what we call entropy. And entropy is this thing that this universe has where everything just kind of just falls apart. It's the chaos of the universe. The second law states that you can't go from a disordered state into a ordered state. For example, if we have pieces of firewood, we can consider the firewood to be orderly because all the molecules are there. We know what it is. It's nice and packed. We can pick up the firewood in one piece. Now, if we set fire to that firewood, we get heat which escapes, and we get smoke which just blows in the wind. And eventually, after the firewood is all used, what we're left with is ash. And the ash is what we call the disordered nature of the log. Now, if you try to get that ash and you just, crush it together and try to make firewood, it can't happen. That's just not how the universe works. The universe can't go from something that is orderly or something that's disordered into order. It only flows one way. Which brings us to the death of the universe. The second law states that entropy always increases. Everything in this universe eventually comes to a state of chaos, eventually comes to a state of entropy. So as time passes, more and more energy will be released. And once that energy is released, it's useless. We can't use it. Think about the firewood. After we burn the firewood, that fire, once it's gone, it's gone. We can't use it anymore. We can't collect it in a jar and store it. It's gone. Which leads us to the heat death of the universe. And what this means is that eventually, over a longer period of time, beyond your lifetime or my lifetime, the amount of available energy in this universe will be zero. It'll all be gone because the universe already used it. So in the long run, the universe will end because nothing is fueling the universe to go on. So why is this sad? Well, all things lead to an end. Things will rot, rust, and break. Everything that exists must cease to exist. This is the will of the universe, and even the universe accepts this fate. All right, the third law, you can't escape. Nothing can ever reach 0 Kelvin. All molecules must constantly move, and therefore nothing in this universe can approach 0 Kelvin, or a system where there is no energy. We came close here on Earth. We super cooled environments, and we got really, really close to 0, but we can't reach absolute 0. There is always something in the universe that can impart energy into a system. And vice versa, you can't ever remove energy entirely from a system because there's always something in the universe that can give the system some amount of energy. And so if you want to think about it, why is this sad? Well, nothing will ever be okay. Nothing will ever be okay. And then our final law, the 0th law, also known as the law that should have been known as law, or the law that should have been known as law number 1, but they discovered it after, or they claimed it after the last 3 laws, and so, well, they were like, we'll just call it the 0 law because scientists like the number 3. So what this means is that if you have 2 systems, and they're all in equilibrium, and there's a third system that's involved, and then eventually that third system is also in equilibrium with the other 2, all 3 can be considered to be in equilibrium. For example, in this picture, if we have a system A and B, and we know that systems A and B are 80 degrees Fahrenheit, and we have system C that's brought along, and it touches A and B, eventually over a period of time, both A, B, and C will all reach the same temperature. This is the 0th law. So why it's sad? Well, eventually, you will no longer be special or unique. Eventually, everything will be the same. And that concludes it, ladies and gentlemen. These are the 4 laws of thermodynamics and why it's the most depressing thing ever.